Good morning, everyone. So today we are talking about what could be the future for the technology for tower cranes, taking into account, I would say, the expectation for the crane operator, for crane driver, and for sure for the company. So future, that's mean nothing is certain, nothing is sure. We are talking about potentials, assumptions, and opportunities. So first of all, I would say the operator is the center of the technologies, the center of the cranes, and everything is around his expectation. So first of all, before driving the crane, we need to access to the driving positions, so that's mean to the cab. So to the cab, you have to access very quickly to the cab, whatever the eye under hook, in a safe environment. It should be painless, and for sure it should be as well comfortable, and there is some change in the business. So then there is the setup. As soon as in the cab, now there is plenty of opportunities to customize, I would say, the way you want to drive the cranes, and you can customize, I would say, if you want reactive cranes, a smooth way to drive the cranes. So then we have the drive himself. So the drive is the efficiency of the job site, is the efficiency for the company. It has a big impact on the duration, on the construction task. So we are talking about a large vision on the job site. We are talking about the efficiency of the crane itself, about the uptime and so on. We are talking about the interface human-machine. We are talking about the comfort of the cab itself, whatever the seat, the joystick, and so on. And for sure, again, we are talking about safety, which is more and more, I would say, demanding. So what could be the future? A new technology is rising. We are talking about the connectivity. We are talking about the total predictive maintenance, about event recorders, about data loggers, about building intelligence model. We are talking about man-to-machine technology. So, and this technology is rising, even if today not all of the cranes are equipped with this kind of technology, but it's coming. So coming back to the basics of the operator's demand, we have to access to the crane again. And now in some country there is some new regulation, new standards. Above a certain eye under hook, a lift is required, is needed, and for sure is for the safety of the driver, is part of the mega trends of the population, is part of the social responsibility of the company to take care of the health of the driver. So we use opportunity. Again, the safety is opportunity for other development, and we take this opportunity to develop a kind of new cab inside the mast with a platform taking into account the task for the erectors. So for erectors, for sure, the driver has to access to the crane every day, and the erector is only once when we erect the cranes, but their tasks are very painful. They have to bring their tool cases, and we use the cab to develop a platform on the top of the cab so that the erector, they can access to the top of the mast to hammer, I would say, the next mast and so on. And it's, again, is part of the accountability of the manufacturer, designer to take into account, I would say, their job. So about the setup, thanks to the data, I would say data display provided by the new technology, now the driver, they can set up, I would say they want to drive the crane, especially for the swing. They want to have a very reactive crane with a sportive crane, or if they have to be more, I would say, smoother drive. For sure, they can access to the different parameters up to a certain level. And then at the end of the day, there is also some menu for the technicians, for the troubleshooter. Everything is secured by different password, passcode, but this is part of the technology of the crane. So for the drive, as soon as the driver is on the cab, as soon as he has set up, I would say, the different parameter for the drive of the crane, we are talking about, I would say, the drive of the crane itself during maybe 8, 10 or more hours per day. And we are talking about the ergonomics, the performance of the technology, especially for the mechanism, about the safety for the driver, but also for all of the stakeholders and the operator on the job site, and for sure for the service to maximize the uptime of the crane. So to drive the crane, we talk about, I would say, the seat, about the joystick. We are talking about automation of the cycles. We are talking about different expectation, vision by camera, anti-collision system, learning procedure, and so on, is part of the automation of the process of the job site. And it's clear and obvious that technology is nothing without, I would say, the man and educated and skilled and trained driver is part as well as the efficiency of the job site. Technology, again, is nothing without the people. So different view of the control, I would say, station. For sure, inside the cab, we have the joystick, we have the seat, and again, it's part of the technology of the change. And if you have just a look on our back, I would say the cab, the current cab today has nothing to do with the cab of the past. So about connectivity, that's the big trends. Thanks to the explosion of the technology in the information technology, and we can talk about the merge between information technology and operational technology. So, and we are just at the beginning, on the site, remotely, with different applications for the driver, for the supervisor of the job site, for troubleshooter, for service manager. We can manage remotely the cranes. We can access to different parameters, and application today are endless. So if you want to have a short view, what could be and what is provided by the application, first of all, we have the alarms. As soon as there is an event, I would say the HSE manager, the supervisor of the job site, he should be informed that something is getting wrong with the cranes. For sure, we have the corrective maintenance, is to make, I would say, the troubleshooter more efficient. We have the predictive maintenance. As you know, the corollary of the Murphy's Law is that the things are breakdown always in the most inconvenient place, in the most opportune time, and the preventive maintenance is part of the efficiency of the cranes and to minimize the downtime. For sure, we can use the technology for the fleet management. If you have several cranes, you can organize your maintenance, you can organize the rotation on your equipment on the yard. Is big part, again, it could be managed by the technology. Is a big part of the business for the rental company, for the manager of the equipment. And last but not least, we can use this kind of technology for the next innovation, because we crane business is entering in the big data, and thanks to different algorithms and so on, we can define how the crane could be used tomorrow for a more efficient, I would say, design. So it was a little bit theoretical, but today we have already some big example, several examples, the way the technology is used to manage the fleet. I already mentioned that, but what is another point of our business is that safety requirements are endless. In some country, the standards, regulation is increasing, and there is plenty of demand to plug some event recorder, data logger, to monitor the crane, to investigate, I would say, what had happened in case of accident. And the technology exists, and it's written in some standards. For instance, in the European directive machinery, that depending the art of the state of the technology, we can be pushed to implement this kind of technology on the crane. So technology can be used as well for a more scientific approach by the engineers. For sure, we perform a lot of tests. For sure, we have, I would say, expectation and the demand coming from the customers and the client. But at the end, we don't know exactly, or we have some ideas. The crane is used on the job site, but indeed, thanks to the record of some data, we know better how the crane is used. And then we can optimize the design, we can optimize the shape, we can optimize the mechanism, following the mean time between failure, following, I would say, the percentage of the utilization of the different motors, and then it can influence the way we will design the next model. So what could be the future? We are already, I would say, involved in the development of this kind of technology, but what could be the, I would say, the far future, the distant future? For sure, we cannot imagine that tomorrow we have a cab or a crane drive like, I would say, a plane. And the future, I would say, should be inspired by what happened in the different industry, in manufacturing the workshop. Today, we can imagine that tomorrow, I would say, the crane driver, I would say the job description will change. We can imagine that to increase the safety again, to increase the efficiency, the job will change. It will move from a crane driver in the cab, managing only one crane, to a kind of supervisor, managing several cranes on a job site, in a clean room, in kind of control room. I would say having a look on what happened on the global job site, a kind of big supervisor managing the safety, managing the different tasks with a program crane. We have already the technology can be used for simulators. As you know, is another point of the technology that exists today, but we have not, I would say, built a bridge between the simulator for training and a simulator used as a driver unit. So another vision is that the crane industry, I would say, not follow, but could be seen as a counterpart of what happened in the manufacturing, the workshop. So the crane can be seen as the robot of the construction site, as we have today a robot in a different workshop, I would say in our own factory, to weld, to machine, to handle the different parts in the plant. And the crane is the key equipment on the job site. It makes the efficiency of the job site, but it could be maybe more efficient with a robotized approach. So today we already talk about collaborative robots. We can develop, I would say, safe trajectories. We can optimize, I would say, the distance of the hook. We can develop some different way to prevent the collision between the cranes. It already exists, but again, in this part of the equipment, the technology is always improving. So, and at the end, we have the communication with the maintenance department, and we can monitor the cranes, I would say, remotely. The cranes is the key assets and will be managed tomorrow like a robot. So, it's a short view. Again, something is already ongoing, something is becoming real. All of the assumption, I would say, maybe will not happen tomorrow. is part of the view, and we are convinced that the crane business today is on the journey for the construction 4.0. Thank you.
Thank you, Eric. Thank you. Does anyone have a question for Eric, please? No? Okay. Oh, we do have one question.
Why are you so confident that tower cranes cannot be fully autonomous one day?
Is not fully? Sorry?
Why do you feel confident that tower cranes won't be fully automatic one day?
It's not confident. It's part of the assumption, as already explained. And I don't want to say that in construction there is a traditional way to address the business. And what we can see what happened with the technology used, I would say, for the steel frames in a different factory. We are talking about lean manufacturing, and if I address the list of all of the initiative of the lean manufacturing, I would say how we can see how the factory have changed in 10 years. I'm not sure, because we must keep humility on this point, but and we are talking about the cost of housing. I'm pretty sure that a big demand to increase the efficiency of the job site. And for me, there is different mega trends. There is the technology, and we talk about, I would say, the people. Being a crane driver is a tough job. And I'm pretty sure that the construction company will be pushed, I would say, to have a different way to drive the crane, because again, it's not sure that following the population which is aging, following, I would say, what want the new generation. You know, that if I ask my son if they prefer to be a welder or working in the IT, I'm pretty sure that I can anticipate the answer, and I'm pretty sure he will move more for IT than to the welding process. This is for all of this kind of, I would say, movement, input, that we can figure out that automation, step by step, automation for trajectory, automation, I would say, for the predictive maintenance, sooner than later, and the demand for the safety organism. It's not certain again, but it should be the trend that we have automated cranes.
Thank you. We've got one more question just over the other side. Gary, thanks. If we make it just as quick as possible, if that's all right. Thanks.
Eric, I may have missed it in your presentation, but where do you see the future with handheld devices for some of this connectivity? Because that seems to be a huge area for everybody at the moment. If you walk anywhere at any time, everybody's got their head down on their handheld device.
I'm sorry, I don't catch all of about the connectivity.
Yes, on the phone.
Yes.
Where you didn't seem to mention in your presentation anything about this.
Yes, I know it exists already, that some iPhone or smartphone is part of the way to use the maintenance. We are not yet at this stage, but when we start to talk about the digitalization of the different assets, you're right that tomorrow is not always a smartphone, at least is an iPad or something like that. The technicians, the troubleshooter, they already use plenty of data on their smartphone. So it's not mentioned, but you're right that maybe not for the supervisor, but for sure, the technician who are in their truck who have to be joined, I would say, by the kind of supervisor in an office. It's clear that one of their key tool tomorrow is you're right, it will be their smartphone. That's right.
Thank you very much, Eric. Thank you.
You're welcome.